In this video, we look at the three-class concentration-based sampling plan, assuming a log 10 normal distribution, using the calculator in the three-class concentration tab. There are several areas in this calculator that we will have a look at, and cells that allow user input are shaded in orange. At the top, we have an area for specifying the sampling plan, including the sample size, the acceptance number, the standard deviation on the log 10 scale, and the two microbiological limits little m and big M, that is the marginal and the unacceptable limits, both also on the log scale. The OC curve that corresponds to this sampling plan is shown here at the bottom. There is also an area for a point of interest, which allows you to calculate the sampling plan's probability of acceptance and rejection for any mean log 10 concentration that you might be interested in. And we'll have a look at this particular area in more detail in a little bit. Finally, there is an area for specifying the consumers' and producers' risk points, which we look at in a different video. And there are also several graphs on the right-hand side that provide some further information. Now, to demonstrate this calculator, consider the microbiological criterion for aerobic plate counts for powdered infant formula, which has n equals 5, c equals 2, a little m of 500 on the arithmetic scale, which on the log scale we can find by typing log 500, and a unacceptable limit of big M, which is on the arithmetic scale 5000 and on the log scale is log 5000. And this plan is shown in book 8 of the ICMSF. Now, for the purpose of this demonstration, let's assume that the standard deviation of APC, the aerobic plate count, is 0.55 in our infant formula product. We can now use this area under the point of interest to calculate the probability of acceptance when the mean log 10 concentration takes on any value that we're interested in. For example, a value of 1 on the log scale. Now, from the information displayed, we can see that the corresponding arithmetic mean is 22.3 and that there is a very large probability of analytical units falling below the marginal limit. So this is the proportion of analytical units that are considered acceptable. We also have a very small probability of analytical units from this food lot of exceeding the marginal limit, but not the unacceptable limit. So this is the proportion of analytical items that we would classify as marginal. It's only 0.1%, and there is virtually no chance of any analytical units from this particular lot to exceed the unacceptable limit. Hence, this particular sampling plan with c equals 2 and n equals 5 and these two microbiological limits has a probability of acceptance of basically 100%, provided the mean log 10 concentration is in fact 1. Now, the three graphs here on the right hand side provide some additional information that you might be interested in. The first plot shows the normal distribution with a mean log 10 concentration of 1, the one that we specified in our point of interest, and we can see that the vast majority of this curve lies to the left of the marginal limit, and in fact this is the 99.9%, And we have the two marginal and unacceptable limits also drawn in on this graph. The second graph here shows the proportion of marginal analytical units, this blue curve, and the proportion of unacceptable units with this red curve for a range of mean log 10 concentrations. And the one that we've entered in our point of interest of 1 is shown here as a dot. And the last curve on the bottom here is the equivalent OC curve, but using the mean log 10 concentration as the x-axis rather than the arithmetic mean that we calculate up here. So if we increase the mean log 10 scale to, say, a value of 3, we see the normal curve shifting with a mean of 3, and our points now fall on these lines, indicating the proportion of marginal and unacceptable units in a food lot when the mean log 10 concentration is in fact 3, and therefore the arithmetic mean, assuming that standard deviation, is about 2,230. Now we can also use this calculator to find a mean concentration which, under this current sampling plan, results in a very low probability of acceptance, for example 5%. So we want this probability of acceptance to be 5% or less. What does the mean log 10 concentration have to be for that to be the case? Well, with the mean log of 3, we're getting fairly close. Let's try some other values. 3.1, getting quite close. Let's take some smaller steps. 3.12, 0.13, and by 3.13 we in fact find that the probability of acceptance has dropped to just below the 5% that we were just thinking of. So you can use this to essentially work out the probability of acceptance under the sampling plan for different mean concentrations. And that means that you can work out what the probability of acceptance might be under any particular situation or for any particular process that you know something about the standard deviation and the mean log concentration.